Okay, guys, hopefully you did these problems before watching the video. I just want to show you, don't you think? I'm sure most of you did it on the calculator, don't blame you, but I just wanted you to see it is a little bit quicker sometimes to not have to enter. Isn't it kind of annoying to enter the matrices sometimes? I find it annoying, but then I'm not as tech savvy as you guys. This one is 2 by 1. Oh, sorry, I was trying to erase that. Okay, we have, what did I say, a 2 by, no, that's a 1 by 2 times a 2 by 1. Okay, so remember, that shows you that it can be done. The fact that 2 equals 2 here in the middle. And what kind of answer we're going to have is a 1 by 1. Isn't that weird? A 1 by 1 is just like one number. So weird. Anyway, so, oh, sugars. Just a second. My battery's running out. I will be right back. Okay. I have my charger plugged in now. So 1 by 2, 2 by 1. Since the columns in this matrix match up with the rows in this matrix, we can do it, and we're going to get a 1 by 1. Okay, and the answer will be 2 times negative 3, which is negative 6, plus 3 times 4, which is 12. So the answer is a 1 by 1, 1 row, 1 column, 6. Okay, this is a 2 by 2 times a 2 by 1. Okay, so the answer will be a 2 by 1. Okay, since the middles are equal, I can multiply them, and the answer will be a 2 by 1. So the answer to B, I'll put up here, okay, you can check your answer. I'm going to multiply this row by this column. So that's 1 times 2, negative 2 plus 5 times 2, 10. Negative 2 plus 10 is 8. And then this row by this column, we have negative 6. 3 times negative 2 is negative 6, plus 4 times 5 is 20. Negative 6 plus 20 is 14. There's the 2 by 1 for that one. And then this 2 by 2, I did a 2 by 2 times a 2 by 2. You end up getting a 2 by 2. And you should have gotten 20, 28, 52, 76. Okay? So hopefully you're okay multiplying matrices and understand a little bit where it came from. Okay, this is just a little exercise in realizing that matrix multiplication is not commutative like regular multiplication is, right? 3 times 4 equals 4 times 3. That all equals 12. Well, not with matrices. First of all, let's see. This is a 3 by 2. 3 rows, 2 columns. This is a 2 by 3. So the answer will be a 3 by 3. Okay, you can put it in your calculator if you want. I'm just going to take this row times this column. So that's my first row, first column. That'll go here. 1 times 2 is 2, plus 6 times 3 is 18. 20 goes there. Then we'll move to this one. 1 times 4 is 4, plus 3 times negative 3 is negative 9. 4 plus negative 9 is negative 5. Negative 1 plus 6 is positive 5. Done with the first row. Let's move to the second row. Second row, 5 times 2 is 10, plus 7 times 6 is 42. 10 plus 42 is 52. Why do I keep circling around? 5, yeah. And then for my next column, second row, second column, 5 times 4 is 20, plus 7 times negative 3 is negative 21. 20 plus negative 21. And then negative 5 plus 14. Okay, and then we'll move on to our last row. And we get 8 times 2, 16, plus 2 times 6 is 12. 16 plus 12. And then 8 times 4 is 32 plus negative 6, 26. And then negative 8 plus 4. Okay. So that's my 3 by 3 that I get. That's AB. If I want to take BA, then that's a 2 by 3 times a 3 by 2. That's true. I can do it since the 3's are equal. But instead of a 3 by 3, I'm just going to get a 2 by 2. Okay, so now I'm taking B first times A. Okay, so for me, I have to put the A. I'm going to rewrite this A matrix beside it. 1, 3, 5, 7, 8, 2. Just so I do it in the right order, I'm going to take this row times this column. So that's 2 plus 20 plus negative 8. So 22 minus 8. Is that what I should have? 14? Is that right? 2 plus 20 is 22 minus 8. Yeah. Okay. And then this row times the next column is 6 plus 28 minus 2, 32. Now I move to this row, 6 plus negative 15 plus 16. 6 plus negative 15 plus, 6 plus negative 15 plus 16 is 7. And the last spot, 18 plus negative 21, it's negative 3 plus 4. Okay, so AB does not equal BA. The dimensions are off. Okay, they're not even the same dimensions. And then you could see it with AB times BA here. Okay, we're not gonna, I can come back and show you that answer later. Oh, I have it here ready to go, but that's all right. Well, we'll do that later. Okay, find AB and BA here. This is a 2 by 1, and this is a 1 by 2. So the answer will be a 2 by 2. So I take, this is weird. I take this row times this column. 2 times 7 is 14. This row times this column. 2 times 4 is 8. And then the other way around, 3 times 7 is 21. And 3 times 4 is 12. So there's our 2 by 2. Now, if I want to do BA, 1 by 2 times a 2 by 1, I'm going to put the 2, 3 here. For my answer is just a 1 by 1, 14 plus 12, right? 14 plus 12, 26. Okay, so again, they're just not equal to each other. All right, I'm going to show you how to solve a matrix equation a new way using inverses. Okay, first of all, I want you to remember that the identity matrix, we already talked about this in 6-1. The identity matrix has this diagonal of 1s and 0s everywhere else. It's basically, if I multiply anything by the identity matrix, I get my own matrix back. It's like a big 1 in our multiplication. It's the identity for multiplication, not for addition, but for multiplication. Okay, so we know when we have an identity, we also need to have an inverse. Okay, just want to make sure you realize no matter what if I multiply this matrix by the 3 by 3 identity, I'll end up getting B back. Okay? Because you take this row times this column, you take 2 times 1 is 2, and then 3 times 0 is 0, 5 times 0 is 0. It's just going to be 2. And that's what the diagonal of 1s will do for you. It doesn't matter if I take B times I or I times B. It doesn't matter what order. It's the only time that doesn't matter is when it's the identity matrix. Okay, now, when I multiply 2 matrices together, if I end up getting the identity, then those matrices are inverses. Just like 3 1/3 are inverses, because when I multiply them, I get 1. 2/5 and 5/2 are inverses because when I multiply them, I get 1. They're multiplicative inverses, right? Well, we have multiplicative inverses for matrices as well. So if I multiply these together, let's see what we get for AB. This row, this column would be 21 plus negative 20. That's 1. Let's go to this column. 3 times negative 12 plus positive 12. That's 0. Okay, let's go to our next row. 5 times 7 is 35 plus negative 35. That's 0. 5 times negative 4, negative 20 plus 21 is 1. So since I got the identity matrix, yes, A and B are inverses. Okay? To find the inverse, there's all these steps. This is the only thing. I'm not going to go through this, okay? I am going to show you how to find the inverse using your calculator. Basically, you make augmented matrices, right? And you keep doing the row operations that we did in 6-1 until the identity is on the left and another matrix is on the right, then that's the inverse. Okay? Now, if it can't be converted, then there's not an inverse. Okay, 0 doesn't have an inverse, a multiplicative inverse. I can't put 1 over 0. Okay, so there are some matrices that don't have inverses. Okay, so what is it? 3, 4, 5, 7. We're going to find these inverses. Let me show you on the calculator how to find it. Okay, so first, of course, you have to enter the matrix in there. Okay, so I'm in trouble manipulating this. Just go like this. Okay, what is it? 3, 4, 5, 7. So I'm going to, let's see, it's a 2 by 2. Maybe I'm just gonna put it in as matrix A. Okay, I'm gonna have to change that to a 2 by 2. All right, so instead of a 2 by 3 like it is now, I'm just gonna change it to a 2 by 2. Okay, and I'm gonna enter 3, 4, 5, and 7. Oh, my gracious, 7. All right, there's 3, 4, 5, 7. All right, we'll quit out of that. To find the inverse, guys, I just type second matrix. I go to the matrix I want, which is A. So I hit enter. And then, interestingly enough, the inverse button, where are you? We raise it. Oh, there it is. Right. Oh, yeah, right under matrix. X to the negative 1, which means inverse. Okay? It's multiplicative inverse. Because what's the inverse of 3? 3 to the negative 1, which is 1/3. What's the inverse of A? A to the negative 1. I literally just click that button. Here's the inverse. Oh, 7, negative 4, negative 5, 3. Okay? Do you see that? Okay, so we can find the inverse just by taking X to the negative 1 button. All right, so we're going to use that idea in order to solve matrices. Here's our equation. Okay? Now, if I have 3x equals 5, don't I multiply each side by the inverse of 3? I know I could say divide by 3, but basically that's how I do it. I either divide by 3 or multiply by 1/3. That's what we're going to do here, guys. Oops, geez. X, y is going to equal, okay, I am going to take my 2 by 2 matrix. I'm going to take the inverse of that and multiply it by this. Just like I took the inverse of 3 and multiplied it. But notice my order does matter, right? In this case, this is a 2 by 2 and this is a 2 by 1. The only way I can do that is if I put the 2 by 2 first and then the 2 by 1. Okay, don't just take this inverse and multiply it, write it first and then this matrix. Okay,